When we look around us in the modern society, we are surrounded by all sorts of gadgets and appliances. Gadgets that are electromechanical in nature and capable of performing various tasks. But little do we care about their origin or why were they introduced in the first place. Everything in this modern society contributes itself to a branch of engineering that hardly anyone thinks or cares about. I am talking about control engineering, and if searched in the internet, it is defined as control engineering or control system engineering is an engineering discipline that applies control theory to design system with desired behavior in control environment. But it is much more than that. It forms the basis of communication system that enables us to communicate with each other seamlessly. Through the applications of control system, the industrial revolution came about. All modern industrial processes utilize control system heavily, and control system enabled humans to build rockets that put man on moon and send rovers to the Mars. So the question is, what it is and how did it become a profound yet a hidden aspect of our daily lives? The use of feedback to control a system has a fascinating history. The first application of feedback control appeared in the development of a float regulator mechanism in Greece in the period of 300 to 1 BC. The water clock of Thesebios used a float regulator. An oil lamp devised by Philon in approximately 250 BC used a float regulator in the oil lamp for maintaining a constant level of fuel oil. Hieron of Alexandria, who lived in the 1st century AD, published a book named Pneumatica, which outlined several forms of water level mechanism using float regulators. The first feedback system to be invented on modern Europe was temperature regulator by Cornelius Drebbel of Holland. Dennis Papin invented the first pressure regulator of steam boilers in 1681. Papin's pressure regulator was form of safety regulator similar to a pressure cooker valve. The first automatic feedback controller used in an industrial process is generally agreed by James Watt's flyball governor developed in 1769 for controlling the speed of a steam engine. The all-mechanical device measured the speed of the output staff and utilized the movement of a flyball to control the system valve and therefore the amount steam entering into the engine. The governor's staff axis is connected via mechanical linkage and believed gas beveled. Be Efforts to increase the accuracy of the control system led to slower attenuation of the transient oscillation and even to unstable systems. It then became imperative to develop a theory of automatic control. In 1968, James Clerk Maxwell formulated a mathematical theory related to control theory using a differential equation model of governors. Maxwell's study was concerned with the effect of various system parameters had on the system performance. Prior to World War II, control theory and practice developed differently in United States and Western Europe than in Russia and Eastern Europe. The main impetus for the use of feedback in the United States was the development of the telephone system and electronic feedback amplifier by Bode, Nyquist and Black at the Bell Telephone Laboratories. Harold S. Black graduated from Worcester Polytechnic Institute in 1921 and joined Bell Laboratories was in the improvement of telephone system and design of improved signal amplifiers. Black was assigned the task of linearizing, stabilizing and improving the amplifier that were used in tandem to carry two conversations over a distance of several thousand miles. On his historic report, Black describes his inventions as, "While was crossing the Hudson River, when the concept of negative amplifier came into my mind, I suddenly realized that if I fed the amplifier output back to its input in reverse phase and kept the device from oscillating, I would have what exactly I wanted, a means of cancelling out the distortion in the output." A large impetus to the theory and practice of automatic control occurred during World War II when it became necessary to design and construct automatic airplane piloting and gun positioning system based on feedback control approach. The complexity and expected performance of these military systems were made necessary an extension of the available control technique and fostered interest in control system and the development of new insights and methods. Prior to 1940, for most cases, the design of control system was an art involving trial and error approach. During the 1940s, mathematical and analytical method increased in number. Another example of discovery of an engineering solution to a control system problem was the creation of gun directed by David B. Parkinson of Bell Telephone Laboratories. In the spring of 1940, Parkinson was a 29-year-old engineer intent on improving the automatic level recorder, an instrument that used strip chart paper to plot the record of the voltage. A critical component was a small potentiometer used to control the pen of the recorder through an actuator. Parkinson had a dream about an anti-aircraft gun that was successfully felling airplanes. Parkinson described the situations as, after 3 or 4 shots, one of the men in the crew smiled at me and beckoned me to come closer to the gun. When I drew near, he pointed to the exposed end of the left rimon. Mounted there was the control potentiometer of my level recorder. The next morning, Parkinson realized the significance of his dream. If my potentiometer could control pen on the recorder, something similar could with the suitable engineering control an anti-aircraft gun. In 1943, 3,000 gun controllers were delivered to US Army. Input to the controller was provided by radar and the gun was aimed by taking the data of airplane's present position and calculating the target's future position.